Hey everyone, so now that we've finished talking about polynomials and a lot of things that we could do, such as multiplying, dividing, adding, subtracting, all those things, we're going to move on to the next part of this topic, which is all about factoring. Um, so, what we have to first talk about are some of the vocab terms related to vocabulary. For example, prime numbers. So, you should know this that prime numbers are referring to numbers that are only divisible by one and itself. So, examples of the smaller prime numbers are things like 2, 3, 5, 7, 11, and 13. Uh, one note, the number 1 is actually not considered a prime number. If a number isn't prime, it would be considered composite number. Composite number is referring to a number that's formed as a product of two integers. So basically, taking two numbers, multiplying them, gives you a composite number. So examples of composite numbers are things like 4, 6, 8, 9, 10, and 12. So again, the only numbers that we have, whole numbers, can be categorized as either prime numbers, if they're divisible by only one n itself, composite numbers, or the number one, which is called unity. So those are the only uh, number categories that we have. Now, the word factor, you may or may not know, is usually referring to a number that can divide evenly into a number. So it's a number that when you multiply by something else will get you another number. So a good example is 2 is a factor of 6 because 2 times 3 equals 6. 4 is a factor of 24 because 4 times 6 is 24. Then we have something called common factors. So if we're looking at two or more numbers, what we can do is we can look at a list of all their factors and then see which ones they have in common. Um, so a good example is the number 2 is a common factor of 8 and 14 because 2 can divide into both of those numbers evenly. And then 3 is a common factor of 12 and 30 because again, it could divide evenly into both those numbers. Now, if you're trying to figure out factors, what I usually recommend is doing this. Start off with writing the number, put it into your calculator, and start dividing by all the prime numbers. Start with the number 2, divide until you can't get any more whole numbers, and then what you can do is divide by 3 until you get to the lowest low number, and then divide by 5 and then 7, and so on, so on. And then the combination of those numbers that you basically like the number of times you divide it by 2 or by 3 or whatever will end up giving you a bunch of these factors. Uh, the reason why we're talking about factors because we're going to talk about what's called the greatest common factor. A lot of times you'll see this as GCF, and this is usually referring to the largest common factor that two or more numbers have. So 8 and 12 have a bunch of common factors, such as 2 and 4. I guess that's it. And 4 would be the greatest common factor of that. 8 would be the greatest common factor of 8 and 16 because 8 can evenly go into both of those. And then 9 is the greatest common factor of the numbers 18 and 27. All right, so let's do a quick practice. Pause video, work on itself. We'll go over in a second. Okay, so what we're going to do is we're going to take the number 96. We actually already know two of the factors, 1 and 96. So we're going to take 96 and just start going through all the numbers. Dividing it by 2 gets me 2 and 48. 96 divided by 3 gives me 3 and 32. 96 divided by 4. We could just keep going through all the numbers. Divided by 5 doesn't get you anything. So 96 divided by 6. 96 divided by 7 is nothing. Divided by 8 is 12. Once you start seeing that these numbers are getting closer and closer, you can basically end up stopping there. So divided by 9 is nothing, divided by 10 is nothing. And now we start to see that when we get to 11, we're not getting any whole numbers. So this is the end of my factors for 96. For 84, once again, I know 1 in 84 factors. Divided by 2, I get 2 in 42 are factors. 84 divided by 3 is 28. 84 divided by 4 is 21. 84 divided by 5 is nothing. Divided by 6 is 14. 7 is 12. 8 is nothing. 9 is nothing. And 10 is nothing. So these are all the common factors. 1, 2, 3, 4, 6, 12. And then after 12, there's no other common factors between them. So the greatest common factor will end up being 12. Now there is a shorter way to do this. I'll show that in this next one. But there is somewhat of a shorter way. So what I'm going to do is I'm going to do this. All right. Now I want you to choose whichever method you prefer. It's really up to you. If you like to do this, that's fine. It takes a little bit of time, but I'm going to do this way. So 21. If I divide 21 by 2, I get that that's not a number. It's not divisible by 2. But if I do 21 divided by 3, I get that this is divisible one time, because 21 divided by 3 is 7. So that also means that 7 divides into it one time. So we have 1 3 and 1 7. Then there's no 5 terms and there's no 11 terms, because again, dividing by 21 by either of those numbers won't get me anything. Now if I do 36, I can see that it goes into it once to get 18, goes into twice to get 9, but after that I get nothing. So it goes in 2 times. Going back, 36 divisible by 3 gets me a whole number. I could divide by 3 again to get 4, but I can't divide it by 3 a third time. So this is only divisible one time. 36 divided by 5 is nothing, so it's not divisible by 5. 36 divided by 7 is not divisible, and I'm not going to even try 11, but it's definitely not it. So the only number that they have in common is 3. And the most that these have that share 3 is one time. This is divisible by 3 once, and this is divisible by 3 at most once. All right, yeah. So my greatest common factor will be 3. I can kind of show how this works a little bit better in the next one. All right. So I'm going to try this again for part 3. See if maybe it might make a little bit more sense here. Now, this method that I'm using is called the prime factoring method. It basically means that I'm looking at all the prime factors in order to figure out what the greatest common factor is. All right, so 4, I'm sure we can all do this in our head. It's divisible by 2, and it could go into 4 2 times. 58, on the other hand, can only divide into uh, 2 can only divide into 58 once, and then we don't get any other whole numbers. 58 divided by 3 is nothing. 58 divided by 5 is nothing. And honestly, we can actually stop at this point uh, because they're not going to have any other common factors. So the only factor that they have in common is 2, and the smallest number between these is 1. So that means here the greatest common factor is 2. Again, you could have done what we did for choice 1, where you just write down all the factors: 1 and 4, 2 and 2, and then this would have been 1 and 58, 2 and I believe it was 29. Yeah, 29, which should be a prime number. So the biggest number that they share is 2. All right. So we can expand this just like what we did before to polynomials, though we do have to be a little bit more careful when we end up dividing by polynomials. What we want to do first is we want to actually try the greatest common factor method, where we just pull out that greatest number. There are other ways, but this is what we're going to focus on first because it is a little bit on the easier side. So the first example is this one. You kind of want to go term by term. So here I can see that this is a 4. This is divisible by basically 2 and 4. I look at 64. It's divisible by 2. And then it's also divisible by 4. So we know that the greatest common factor will be 4. And then we could do the same thing for the x's. This is 1x, and this is 2x's. It could be divisible by x or x squared. So the greatest common factor here would be an x. So my greatest common factor will end up being 4x. And that's pretty much it. We can then figure out do what we did before with dividing polynomials. Take 4x minus 64x squared. Divide it by 4x. Split it up into different parts. And then divide them. 4x divided by 4x is 1. 64 divided by 4 is 16. X squared divided by x is x. So this ends up becoming 4x times 1 minus 16x. So again, like I said, we're doing a lot of the same stuff that we did in the previous part with the dividing polynomials, but now we're kind of almost doing it backwards. Originally, we would start with this expression and then expand it out to get to here, but now we're going to step backwards. All right, so here's the next one. Once again, I can look at all the factors. The factors for 24 are 2, 4, 6. I forgot to put in 3, 6. 8's a factor, and 12's a factor, and then 24. 108, what you can do is just almost work backwards. 24 is not a common factor. 108 divided by 12 gets me 9. So 12 is actually going to be our largest common factor here. This can be x or x squared. This is x squared, x cubed. So the x squareds are the common factors. So that means our greatest common factor here is going to be 12x squared. And then again, we take the expression divide both terms by 12x squared. (24) divided by 12 is 2. X squared divided by x squared cancels out. 108 divided by 12 is 9. X cubed divided by x squared is x. And we're left with 12x squared times 2 minus 9x. And then this one, so it's a little bit longer, so it's going to take us a bit of time. Once again, here the factors, if I look in the calculator or just from experience, numbers that go into 16 are 2, 4, 8, and 16. 24. So now what we just need to do is see which of these numbers can go into both of these. So 24 is divisible by 2, it is divisible by 4, and 8, but it's not divisible by 16. So that's not my greatest common factor. And then 4, common numbers 2, 4, and 8 also work. So that means 8 is my greatest common factor. X, this has 1x, but none of these have x's, so that's nothing. This has a y and a y squared. This has a y and a y squared. And this has a y and a y squared. All three of these have the same common factor of y squared, so this is the next part. This one has a z, but none of the other terms have z. So that means my greatest common factor is going to be 8y squared. So I'm going to take the expression and divide each term by that greatest common factor. So divided by 8y squared, 8y squared, 8y squared. 16 divided by 8 is 2. Y squared by y squared cancels out, so all that's left is that x. 24 divided by 8 is going to be 3. Y squared by y squared cancels out, leaving me with just the z. And then 40 divided by 8 is 5. Y squared divided by y squared cancels out. So I'm left with this as the remainder. So then I just, again, write this times by 8y squared. And that's what you end up doing. It's a little bit of extra work, but for the most part, you can end up getting these factors very quickly the more you practice them. You'll notice that it's always a lot of similar numbers, so you should be able to do this in your head eventually. All right, so we'll do a few practice. Pause the video, work itself. We'll go over in a second. All right, so right off the bat, I can actually already see what my greatest common factor is. So I'm going to first look at the smallest number. This one, factors are 2, 5, and 10. But looking at all these, I know that 10 is going to be my greatest common factor. And then I also can see that these all have x's in it. And the smallest x is going to be the largest number of x's that goes into all of them is this, just 1x. So then now what I can do is divide all these terms by 10x, and I end up getting 4x cubed here, 2x here, and minus 1 here. So my factoring ends up being like this. All right, and then for this one, so once again, my factor, I know that 4 actually goes into 8 as well as itself. So this is definitely my greatest common factor of 4. Both of these terms have x's, so x is also going to be one of my factors. There's no exponent, so I don't have to worry about that. Once again, I also have a y in both terms, so I definitely have 1y as my greatest common factor. The smallest exponent is 1, so that's going to be the smallest here as well. So all of them are 4xy. That's my greatest common factor. Then I'm just going to divide all these terms. So negative 8 divided by 4 is negative 2. Xy divided by xy cancels out. Plus 4 divided by 4 is 1. X divided by x cancels out. Y squared divided by y is just a y. So I'm left with this as my factor. All right. Next questions. Pause the video, work itself. We'll go over in a second. Okay, so let's see. Once again, I want to start with my smallest number. That's usually the easier one because that's going to help filter out the rest. So 2 is a factor, 4 is a factor, 5 is a factor, and 10 and 20 are factors. 2 times 10 is 20, 4 times 5 is 20. All right. And then I could just compare that to all these. So I'm actually going to compare it to this one first. So I know 2 is a factor of 36. I also know that 4 is going to be a factor of 36. 5 will not be a factor of 36 because 5 can only divide into numbers that end in 5 and 0. 10 and 20 also can't be factors because they can only divide into things of divisible by 0. So that means 4 is probably going to be my greatest common factor, but let's just double check that it goes into all these. So 4 does go into here, and 4 also goes into here. So my greatest common factor is going to be 4. There's a p in each of these terms. So p is also going to be a common factor, and the smallest p exponent is going to be a 2. So 4p squared is my greatest common factor. So now what I'm going to do, divide all these by 4p squared. So 36 divided by 4 is going to be 9. P to the 5th divided by p squared is p cubed. 40 divided by 4 is 10. P to the 4th divided by p squared is p squared. 160 divided by 4 is 40. P cubed divided by p squared is p. And 20 divided by 4 is 5. And p squared divided by p squared cancels out. So it's going to be this times by 4p squared. All right, part 4. They basically we need to figure out who's correct, Jax or Michael. Jax thinks this is the greatest common factor, while Michael thinks it's this. So let's double check. 5 does go evenly into all these. So this goes in 3 times, 2 times, and 5 times. So the greatest common factor, definitely 5 is part of it. Now let's check if it's x or x squared. So this has an x squared, this has 1x, and this has an x squared. We go with the smallest exponent. So x is going to be the greatest common factor because it's 1. And then here with the y, so they all have a y term. 2, 3, 5, and 2. So the greatest common the smallest exponent is 2. So we find that Michael is the one who is correct. Jax made the wrong mistake of putting a square on that x. And that's it for that. All right, here's the next question. Pause the video, work itself, and we'll go over in a second. All right. So coefficient-wise, there is no thing to factor out of here. So we're not going to do that, but we can look at the variable. So again, there's an x in these two terms, and the smallest exponent is x to the first. So x is our greatest common factor. And if I divide in x from both of these terms, I'm left with 8 minus x. You can always double check by just doing the multiplication and seeing if you get what you started with. So that's one of the nice things about factoring is that you can always double check. Now six is a little bit tricky because we don't actually have it written out in standard form. But if you remember, the whole idea is we're looking for factors that they have that they share together. So we actually can see that there is a factor of these two terms that they share. They share 2 plus y, because this is multiplied by 2 plus y and this is multiplied by 2 plus y. So I'm going to pull out 2 plus y from both these terms, and then I'm just going to leave what remains. There was a 3x in that first term, and there was a 4 in the other term. So this would be the factors for this expression. The answer to this last question, of course, is no. And that's one of the things that we're going to see later on, is that we will end up doing factoring where we end up getting binomials or trinomials. Again, basically exactly what we did before, but in the opposite direction. All right, next set. Pause video work itself. We'll go over in a second. All right, so if I go through again all the factors, the greatest common factor for all these terms is going to be 9, because 9 can easily be divided by both of them. And there's an x in each term with the smallest exponent of 1. So 9x is going to be the greatest common factor. Dividing each of these terms, I end up getting x squared here. I get 4x over here. And then I get plus 2. So this is my factor for number 7. For number 8, 5 is going to be my greatest common factor. A b squared, since that's the smallest exponent. C squared. And there is no d. So when I do this, I end up getting 4. A's cancel out. I'm left with 1b. I'm left with c squared up top and a d. And then here it's basically just 1. And this would be my factor for that one. All right. We have 2 more questions, so pause video work itself. We'll go over in a second. All right. So what they want us to do is figure out the dimensions of the length and width based off the area. Basically, what we have to do is find the greatest common factor. So 14 and 21, I already know that the greatest common factor is going to be 7. M is shared by both of these terms with the smallest exponent 1. N squared is shared by both. And P is shared with the smallest exponent 1. Then I divide each of these terms by 7 m n squared p, 7 m n squared p, and I end up getting 2. The m cancels out with one of those m's. The n's drop out, and the p drops out. Plus 21 divided by 7 is 3. M's cancel, n squareds cancel, and then I'm left with a p in this term. So this would be the length, and this could be the width, or vice versa. All right, here's the next question. Pause video work itself. I'll go over in a second. All right, so this is basically question 4 again. We just want to see what the greatest common factor is. So let's see. 7 and 49, the greatest common factor, at least the coefficient, will definitely be 7. There's an r in both with the smallest exponent 1. There's an s in both with the smallest exponent 1. And there's a t in both with the smallest exponent 1. So it looks like Paolo is correct because he has the smallest t, because t squared does not go into both these terms. And that's pretty much it. Hopefully that made a little bit of sense. If you're having trouble, identifying factors, let me know. Here's the exit question, so you can pause the video, work on this. All right, so we're going to go over this stuff. If you have any questions, please let me know as soon as possible. We'll discuss some of this stuff in class. Otherwise, good luck and have a great day.